Welcome to The Explainer. Today, we're going to tackle something that trips up pretty much every Python developer at some point, handling dates and times. It really sounds like it should be simple, but oh boy, it can be a real headache.
I mean, it should be easy, right? But let's be honest. If you've ever pulled your hair out over a time zone bug or some random date parsing error, you know it is way more complicated than it looks. The real world is just messy. You've got time zones, daylight saving, all these different text formats. It's a lot. So, to get a handle on all this, we're going to break it down into 5 key parts. We'll start with the basic building blocks, then get into the most important concept, naive versus aware date times. After that, we'll tackle time zones, do a little math, and finish up by turning messy text into clean time data. Okay, first up, Python's time keepers. Let's start at the very beginning. Before you can build anything cool, you gotta know your tools. And in the world of Python time, that means getting familiar with the core objects in the datetime module. So Python basically hands us 4 main tools. You've got date, time, and datetime. Think of these as pins on a map. They mark a specific point in time. But then you have time delta. This one's different. It's not the pin on the map. It's the distance between 2 pins. It represents a duration, like 30 days or 5 hours and 15 minutes. And trust me, this little guy is the secret sauce for doing any kind of math with time. All right, section 2, naive versus aware date times. Now listen up, because this is probably the single most important concept we're going to cover. I'm not kidding. This one thing is the source of so many bugs. Getting this right is absolutely fundamental. So here's the deal. Whenever you create a datetime object in Python, by default, it's naive. Think of it like a clock on a blank wall. It says 3 p.m., but where? Is it 3 p.m. in London or 3 p.m. in Los Angeles? A naive object has absolutely no clue. And this, right here, is exactly how you end up scheduling a global meeting where half the people show up 3 hours late. To fix this, we need to make our object aware. And how do we do that? We attach something called a tzinfo object to it. You can picture the tzinfo object as a little tag that says, hey, this clock is in the Tokyo time zone. It's this little packet of data that holds all the rules, giving our 3 p.m. that crucial context and anchoring it to a real place on the map. And this chart just lays it all out, crystal clear. On the left, you've got naive, no context, totally ambiguous. On the right, you've got aware, it's explicit, we know exactly what we're talking about. And really, when you look under the hood, the only thing that separates them is whether that little titsinfo attribute is set or not. That's it. It sounds simple, but man, it makes all the difference. Okay, section 3. Now that we've got the whole naive versus aware thing down, let's dive into the really fun part, mastering time zones. This is where we get into the real-world messiness, like those super annoying daylight saving rules. Now, Python's built-in stuff is okay for simple things, like a fixed offset from UTC. But the second you need to deal with something complex, like daylight saving time, forget it. The standard library just can't handle it. For that, you absolutely have to bring in the big guns, specialized third-party libraries. And speaking of those libraries, let's talk about one of the most popular ones, PyTZ. There is a huge pitfall here that gets everyone. It seems totally logical to just pass the time zone right into the constructor when you create the datetime object. But don't do it. It's a trap, and it will lead to some really weird, hard-to-find bugs. Don't just take my word for it. The library's own documentation screams this from the rooftops. They are super clear about it. You should not attach their time zones directly. Instead, they tell you exactly what to do. And here it is. The right way to do it is always a 2-step dance. First, you make your plain, naive, datetime object. Then, you take your time zone object and use its .localize method to make it aware. This is the only way to be sure that all those tricky edge cases are handled correctly. So let's boil it down to 3 essential operations you'll be using all the time. First, making a naive object aware, you can use .replace. Second, converting an already aware object from one time zone to another. For that, you want .asTimeZone. And finally, a little pro tip just for PyTs. If you do any math that crosses a daylight saving boundary, you'll want to call .normalize afterwards to clean things up and make sure the time is right. Okay, on to our 4th section, the art of arithmetic. We know how to represent time correctly now, so what about doing math with it? Like, how do you figure out what the date will be 120 days from now?
Well, the hero of this story is that time delta object we talked about earlier. Remember? It's not a point in time. It's a duration. It's that span of time, like 2 days and 3 hours. And this is the magic wand we wave to add or subtract time from our date times. And using it is honestly as easy as 1, 2, 3. You get your starting time, you create a time delta for the duration you care about, and then you just add them together. It's that simple. Python makes this part incredibly intuitive. All right, last section. Let's talk about the real world, which is messy. We're talking about taking all that ugly text you get from log files, from APIs, from user input, and turning it into a beautiful, useful datetime object that our code can actually understand. So you've got a few tools in your toolbox for this, and you've got to pick the right one for the job. If the format is simple and you know exactly what it's going to look like, yeah, the built-in strip time works fine. If you're dealing with the strict ISO 8601 standard, grab the ISO 8601 library. But for pretty much everything else, especially the weird stuff, dateutil is going to be your absolute best friend. And this is where dateutil just feels like magic. I mean, check this out. You can throw a whole sentence at it, turn on fuzzy mode, and it will actually find and pull out the date and time. This is an absolute game changer when you're dealing with unpredictable input. A total lifesaver. Okay, so let's wrap this up with the key things to remember. Number 1, always know if your date time is naive or aware. That's the foundation for everything. Number 2, for PyT, use .localize. Don't pass it into the constructor. 3, all your date math, use time delta. And finally, when you're parsing strings, let a powerful library like dateutil do the heavy lifting for you. Look, truly understanding how to handle time in code, it's like a programming superpower. Seriously, it opens up the door to working with global data, scheduling crazy complex events, analyzing trends, the whole 9 yards. So, now that you've got this power, the only real question is, what are you going to build with it?